Good afternoon, everyone. Today we're going to be working on IXL assignment P9N, Solutions to Inequalities. So let's first refresh our memory on what our inequality symbols are. We have four different ones. We have our greater than and less than, and then the ones with the lines underneath are greater than or equal to and less than or equal to. So notice that line underneath is like half an equal sign. And with those, it's meaning, we'll go through an example here in a minute, that your answer could be greater than that number, but it could also be equal to it. That's what the or means. It could be greater than it, or it could be equal to. And for the less than, it could be less than, or it could be equal. Where when we have our first two symbols here, just the regular less than and the regular greater than, your number cannot be equal to that. It has to be at least a small portion greater or a small portion less. It can be like a decimal. So let's say we had something like 5 1/10 is greater than 5. That would be okay. It can be a small amount, but it has to be greater. Where if it's the greater than or less than, you could have something like 6 is greater than or equal to 5, but you could also have 5 is greater than or equal to 5. Both of those are true statements because they both work with that inequality. Now, I kind of started talking about solutions and things that work. When you're using inequalities, sometimes you can use them to compare numbers. That's what we were just doing on that previous slide. They're comparing numbers. Other times you can use them similar to an equation where you may have variables involved. So when that comes to play, when we have our answers, otherwise known as our solutions, let's kind of look at how to solve that and what that means with our answer. So in an equation, there is only one answer because you get a number and it's equal to that, and it can only be equal to that exact number. But when we have inequalities and we're talking about their solutions, there are a range of numbers that could possibly work. So if we go to solve this, x plus 2 is greater than 5. We would subtract 2 from both sides, and we have x is greater than 3. Well, that means any number greater than 3 is a possible solution. So x could be the value of 4. That's greater than 3. X could be the value of 100. That's greater than 3. X could be the value of 3 5/10. That's greater than 3. X can even be fractional values. It could be 7 1/2. As long as it's a value that's greater than 3, it is a possible solution and it would in fact work. Anything that is equal to 3 or less than 3 would not work. All right, let's head on over to IXL and put this concept into practice and go through and look and see if given values could be a solution to the inequality statement that is given. All right, here we are on IXL, and we are on assignment P9N, Solutions to Inequalities. Please remember that IXL has some awesome resources here too, so if you would like a little bit more help after this video is finished, you can check out their example and the video that they've created for you as well. All right, our first question here says, is J equals 7 a solution to the inequality below? And our inequality says J is greater than 7. Because remember with these inequalities, a lot of us, maybe learned it as, an alligator and it's eating the bigger number. It's opening towards that greater side. So that's how I know this is pronounced. J is greater than 7. Well, if we were to do a little bit of substitution here, and it's telling us that J is equal to 7, so we substitute that value in for J. That means our statement would read 7 is greater than 7. Is that true? No, 7's equal to 7. And that's just a regular greater than sign, which means our answer is no. It is not a solution. It does not work. All right, let's try this one. Is P equals 4 a solution to the inequality below? 4 is greater than or equal to P. All right, there's two different ways that we can look at this, and I'm going to do this problem in both formats. The first way is to do it like we just did, where we're saying, all right, to help us visually, I can see here that P is equal to 4, so I'm going to substitute, I'm going to plug that in so I can visualize my inequality statement here and make sure that it's correct. So 4 is greater than or equal to 4. Well, because this one here has that line underneath, it has that or equal to option, this does check out. It would be a yes, it does work. Another way we can look at this is whenever you're given an inequality statement and it's written backwards, as I like to say, where, instead of having your variable, your inequality sign, and your number, it's written like this, where the number's first and the variable second. You could flip that whole thing around because when it's written backwards, if you're trying to do this in your head, it takes some backwards thinking. Like you have to say, okay, 4 is the greater number, and it can make it a little bit harder to get the answer correct. So if you don't want to substitute and plug in like I did, so you can visually see if it's a true statement or not, you could flip your inequality statement around and have it written, the more common way. If you do that, you just have to be careful to flip the whole thing. So we're flipping our P and our 4, they're switching places, but then that also means that our inequality sign needs to flip as well. Because no matter which way we write it, in order for it to be equivalent, in order for it to be representing the exact same thing, it has to be opening towards the same number. So in the first example here, it's opening towards the 4. It's eating the 4. It's eating the greater side. So if you flip it around, that's why we have to also flip the inequality around, because it still needs to be opening towards the 4 and eating that 4. So now it would be read as P is less than or equal to 4. And on some problems, that may make it a little bit easier for you to pick the right answer. I'll go through these two different ways again if we get to another problem like this. This one, because it's 4 and it could be equal to, it may not have been as tricky, but I'll make sure to go through it again. All right. This actually is exactly what I was looking for. This is what I was saying, how sometimes we got to flip them around to make it a little bit easier. So this is a multi-select question. We want to select all of the solutions that work. So we'll test it out one method for 2 of the options. We'll test it out the other way for the other 2. And then hopefully this will clear up any confusions that you may have had on that last example on the 2 different ways you can deal with these problems. So first way is to just substitute, so it doesn't really matter how it's written. We can substitute 1 in for 4, and that would give us 4 is greater than 1. That is true. This one works. Now, if we do the second one and substitute and plug it in again, that means we have 4 is greater than 9. Was that true? No, it is not. 4 is not greater. X that out. Doesn't work at all. Let's say you didn't want to write things out. You were trying to do it all in your head, or you had another problem and you were trying to solve. We can take our inequality here and we can flip it around so that way it's a little bit easier to look at. So if we flip it around, we have to flip the whole thing. So the P and the 4 flip, but so does your inequality sign because it needs to continue to be opening towards that 4, eating the 4. So now we have P is less than 4. So if we look at this, 4 is less than 4. Nope, it's equal to it. That's not right. We look at our last one, 5 is less than 4. Nope, that's not right. Doesn't work. So in this case, there happens to be only one solution that works. But you will get problems where there are more than one that works. That's why it always says select all that apply, and you need to check each answer to pick all that work. All right, let's do just two more examples here. We want to know which one of the following solutions, or which of the following are solutions to the inequality below. Select all that apply. All right, if we look at our first one here, let's switch our color up to blue. We have 10. So if we were to write that out, 10 is less than 11. Yep, that works. Check. Now x is equal to 1. 1 is less than 11. Yep, that works. Now we have x is 5. 5 is less than 11. Yep, that works. And then now we have 8. 8 is less than 11. Yep, that works. So look at this. Last time we only had one answer. This time you need to click all four. So just be careful to double check before you hit submit to make sure you've clicked all the right ones. Ooh, all right, now we're kicking it up a notch. So we may actually do a couple more of these since this is a slightly different type. We have an equation here, but it's the same process. We're going to substitute, we're going to plug these values in for m and see if it works, see if it makes a true statement. If we look at our first one here, we have 120. So 9 is greater than 120 divided by 8. I'm choosing to use my calculator. You do have permission to do that if you want, or you can do it by hand. But 120 divided by 8 is 15. So this says 9 is greater than 15. Well, that's not true. So the first one does not work. All right, second one here, m is 48. So 9 is greater than 48 divided by 8. 48 divided by 8 is 6. 9 is greater than 6. Yeah, that one does in fact work. Next up, m is equal to 88. So 9 is greater than 88 divided by 8. 88 divided by 8 is 11. 9 is greater than 11. Nope, not true. Doesn't work. Last but not least, m is equal to 136. So 9 is greater than 136 divided by 8. When I put that in my calculator, I have 9 is greater than 17, and that is not true. So only one of these is a solution to the inequality. All right, final example here. We have 78 is greater than 8z. Let's go ahead and do this one maybe a little bit more in our heads because multiplication may be a little bit easier to do in your head than division. So if I'm going to try to do it in my head, I am going to still start off by flipping this inequality around because that's going to make it a little bit easier. So I'm going to rewrite this as 8z is less than 78. And I know that I flipped this properly because the inequality is opening towards the 78. It's still eating the bigger side. So now if I go through and substitute all of these values in for z, let's do the 7 first. That means we'd have 8 times 7, which is 56. Is 56 less than 78? Yes, it is. That one works. All right, now we have z equals 4. So we'd have 8 times 4, which is 32. Is 32 less than 78? Yes, it is. That one works too. All right, now we have z is 5. So 8 times 5 is 40. Is 40 less than 78? Yep, that one works. And then last but not least, we have z equals 11. 8 times 11 is 88. Is 88 less than 78? No, it's not. So the first three work, the last one don't. So the first three are possible solutions to the inequality. The last one isn't. All right, it's now your guys' turn to try. I hope this video helped. Make sure that you're working on this assignment. Check out IXL's video right here if you need a little bit more support. And as always, if you have any questions, please reach out to your teacher. Bye, guys. Good luck.